All right, guys, so several things I would like to mention. The first thing is that Professor Suzuki mentioned that review for final is posted, or I haven't read the message, will be soon posted on my open whatever it's called, my open math, I think, right? You know what this nonsense is called. Good. And so you should start whenever you can, as soon as possible, practice those questions. We will try to arrange reviews. Those reviews will be outside of class, as we still have lots of material to cover. All right, so what you need to do is, of course, guys, if your goal is to survive the exam, which will be timed, not like my exam, it will be timed. It's worth 40 points. You must practice those questions. You must be solving them rapidly. Do you understand? Another thing is, I'm not sure if that's a good analogy or not. So you always, I hear some of you, of course, have it in your mind. Others ask this question: why do you study? Why do you do that? Why do you need to know this or that? It's not the need to know. Does anyone here exercise? Let me just know that. Does anyone here does push-ups or pull-ups or runs or anything of that sort? Do you do that? And now look at it. If from the perspective of somebody who is training, why do this? It's a futile motion. Do you agree? It means it's ridiculous even, right? You do this like this. I mean, if there is a point to it, it's to make you stronger. So the same thing with the mathematics is to hopefully make you smarter. Just like it's hard to be strong, it is very hard to be smart. Maybe impossible, but that I'm a pessimist, right? And yet I try. Yes, of course. It's very hard to do exercises, right? There are some things I'm trying also to do. It's very, very hard, physically as it is mentally. Well, I don't know about everything online. You understand that through the years of teaching this particular subject, even at Brooklyn College, I taught it a few years, I've noticed deterioration in 5 years of teaching it. In other words, it gets longer and longer to, and I know why it happened. It's because they eliminated some exams and they made entrance into calculus easier. So it's getting watered down. But hopefully we can correct for that. Good. Let's go and talk about logarithms, guys. Let's quickly review, and you will help me, please, as fast as you can. When you have a short day today, please tell me the following, guys. And I don't want you just to remember. Tell me question number 1. How would you figure out the derivative of ln of x from knowledge about the derivative of e to the x? So I want a few steps. I don't even care for you to finish this. A few steps to indicate that you understood or understand. What's the mental process? Why is it so easy to figure this answer? Okay, that's very good, Francis, correct. So very simply, you can do this, guys. You can say, well, let y be equal to ln x, which means that if I apply e to both sides, that means that e to the y is equal to e to the ln x which is just x. Yes? And then y is the derivative I'm interested in. I take the derivative of this side, and what do I get? I get that e to the y times y prime. That I use implicit differentiation. I presume that ln x is differentiable. You agree? I presume it's differentiable, and because I don't have a formula for its derivative, I just write y prime. That's implicit differentiation there. So I have e to the y prime is equal to the derivative of x, which is 1, which means that y prime is equal to 1 divided by e to the y, which is, what is e to the y? Do you see this, guys, here? E to the y is x. So this is 1 over x. Even by carrying out this procedure, you might not understand what's happening. It's already good if you can come up with this procedure on your own, which you should. Without my explanation, you should be able to come up with such ideas. But the idea here, guys, is what? Why is y differentiable? Why is ln differentiable? Because geometrically speaking, you are looking at the same curve, right? Remember that the conversation. Ln x is the same curve as the exponential, just you change your perspective. Yes? So this is the story. This is the curve y equal ln x, and that's viewed from this point of view, but it is the curve x equal e to the y when you view it from the perspective of the orange arrow. All of this means is that you are staring at the same curve. And when you are saying that the curve is differentiable, let me remind you for 100th time, you are saying that the curve is a chain of microscopic line segments. And when you are asking for the derivative, you are asking for the slope of those line segments. And that is very subjective. It's a matter of perception. It's a matter of point of view. Do you agree? So slope is not, so a different point of view will show, well, careful, Francis. What do you mean by a different point of view showing the same numbers? What numbers? If I'm talking about a slope, if I'm talking about a slope, then the slope as measured from the perspective of the orange arrow will be what? If you measure it from the perspective of the orange arrow, you see, if you start at this point, which is y, this point is e to the y. So the slope at the point y is e to the y, which is simply x. Okay, so the slope is the corresponding x coordinate at any point y where you're standing, from the point of view of the orange arrow. From the point of view of the blue arrow, it's 1 over x. Yes, because the blue arrow has a different sense, has a reverse sense of vertical and horizontal. For that reason, guys, which I hope, I mean, at least 1 or 2 of you will go to Calc 3 or to something more interesting in higher mathematics, you will understand that perspective is that for more advanced ideas for multidimensional calculus, the slope becomes less important as much as what's important is that you are seeing a tangent line. So you are defining derivative in a different form. Good. So the answer is that the derivative of y prime is 1 over x. You should be able to see that ideally or just by the geometry. You can do that abstractly, that assume that there is a derivative, then the derivative must be 1 over x, but I right away know that the derivative exists because it exists for the other perspective. Understood? Now, we mentioned too, is we know that the derivative of any a to the power of x, I can figure that out by, again, by wishful thinking. I can convert a to the x to the derivative of e of ln a to the x. Do you agree? Because e and ln, they cancel each other out. And I put an e there because I like taking derivatives where the base is e. And what is that? This is, by logarithmic properties, the derivative of e x multiplied by ln a. And the derivative of e x ln a will be e to the power of what was the exponent multiplied by the derivative of the exponent, which is by ln a. Yes? And then I look at this expression, e x ln a is simply e ln of a to the x. I bring the x back. And this can be then reduced to a to the x ln a. Yes? And then I can figure out 3. What is the derivative of an arbitrary logarithm? The derivative, well, with respect to what? A is assumed to be constant, Francis. If I took the derivative with respect to a, then it would be 1 over a. But a here stands for a fixed number. So a is 3 or 4 or 7. And so when I take the derivative, it's just ln of a is a constant. It's just like what is, you see, the difference is between ln of x and ln of 2. Ln of 2 is a number. Ln of x is a function because it requires x to be specified. So the derivative of, please tell me and figure it out, the derivative of log base a for any a of x, remind me, what is this thing? Exactly the rule, and the rest of you. The answer is, what's the answer? Yes, so what can we do here, guys? So we can think of this in 2 ways. One way is, of course, I can set y equal to log base a of x, and I can take a to the power of y. That would be equal to x, and then the derivative here is the derivative of a to the y is a to the y ln a times y prime equal to 1. So y prime equals to 1 over a to the y ln a, which is 1 over x ln a. Yeah? So that's one way to think of this problem. I can also, just the same, I can realize that For instance, what is log base a of x in terms of ln of x? I want to convert to ln because basically every logarithm can be calculated using only the natural logarithm. You understand, guys? Why would I consider that is because from my point of view, once you kind of get more familiar with this functions, you realize that one function is very well defined. You know everything about it, but other logarithms, maybe other work is required to even justify their existence. But what? Yes. Yeah, so you can have the change of basis, right? So this is just change of basis. Now, why would you want change of basis? It's just that's in fact how, let's say, maybe machines calculate. You understand? I mean, you can just translate one entity into something that machine understands right away, and you can calculate every logarithm in terms of the natural logarithm, for which you can come up with nice formulas. So how do you do that? So what do we know about log base a of x? Yes, so log base a of x, we're going to convert it to ln. So how am I going to do that? Well, let me see. So I know that x is equal to a to the power of log base ax. But I want not to have base a, I want to have base e. So I write this as e ln of a raised to the power of log base ax. On one hand, I have this formula. On the other hand, I can do the same for x. So x is what? So what is x? X is equal to e to the power of ln x. It is then equal to e to the power of ln a log base ax. From which point they have the same base, so you understand that those numbers are the same. So this number and this number must be identical for any x. There is no such a thing as have to do it anyway. It's just I'm showing you the different movements. I'm showing you here is a street. You can go forward, you can move to the left, you can move to the right, you can move around. It's not a particular problem you're trying to solve. You're trying to be familiar with the city. It's a tour of the city. Yes? And then you decide where you want to go. I'm just giving you a tour of Rome. So what is this? This is ln x equal to ln a log base ax. And what you can do is just solve for log base ax. So you see that log base ax is simply ln x divided by ln a. So in other words, every logarithm can be completely described by calculating only using the natural logarithm. That means that from this point of view, there is only one logarithm that you need to have. Yes? Every other logarithm has this relationship. Good. So now let's see what we can do with logarithms. Suppose, guys, you would be asked to calculate this problem. Okay. Suppose I asked you find derivative of the cube root of x plus 1 multiplied by x to the power of 5 sine cubed x divided by x minus 5, let's say x squared minus 5 to the power of 100. Yes, something like that. So if you had to find the derivative of this expression, you can of course proceed and use the shortcuts that you learned before. But you notice that this would be quotient rule and product rule. Do you agree? You would apply quotient rule and product rule, and it would be very tedious. So here is what you can do instead. This is called logarithmic differentiation. So what you do is you let this expression equal to y. Okay, let it equal to y, and then observe that I can take the logarithm of y. So I take ln of y, and that would be ln of the expression around it. So it would be ln of, I don't want to copy it, it's a bit redundant, so ln of this expression. You agree? Right, I mean, you understand what I'm doing, guys. Now, before I proceed, would anybody, before I explain further, why would I bother and say logarithm? Why would I take logarithm of that expression? Would anybody have any idea? Like, why take logarithm? I said, okay, y equals to this, fine. Why I take logarithm? But specifically, what am I striving to do? So it should be easier if I'm correct, but why? Why is it easier? What is why logarithm? Why didn't I decide to take sine of the expression? And more specifically, guys, what does a logarithm have that I like? Logarithm of product is the sum of logarithms, right? Logarithm of an expression to a power, I can take the power and drop in front of the logarithm. So I can decompose this expression into more manageable bits. Yes? So for instance, why did I do that? I don't like quotient rule. You agree? I mean, I'm sure if you try to use it many times, you are not that happy when you have to use quotient rule. And especially not happy when you have to use quotient rule and within it product rule. Or product rule and then it quotient rule. Then you add chain rule to that and it's a big mess. So you try to make it simpler. And then if I apply logarithm to this expression, look at what happens, guys. It's the numerator. I'll just write it for a moment slowly. But it's the numerator, ln of the cube root of x plus 1 times x to the 5 sine cubed x minus ln of x to the 5, x to the second power, sorry, minus 5 to the 100. You see, I transformed quotient into a difference. And each of the products I can still manage, right? Each of the products I can still manage. And what happens to the numerator if I do that fast? Look at it, this is 1/3 power. So what it all together becomes is 1/3 logarithm of x plus 1 plus 5 logarithm of x plus 3 logarithm of sine x. Do you agree? That's the numerator, and the denominator is simply minus 100 ln of x squared minus 5. Are you with me, guys? You understood what I just did. It was a bit tedious for me to write each step again and again. I mean, I'm just using logarithm of a quotient is difference of logarithms. Logarithm of product is sum of logarithms. And then I move the powers down. You have the logarithm of an expression to a power is the power multiplied by logarithm of the expression. Yes? All the logarithm rules that we learned and that you should be able to justify at least to some extent. Here it is. Do you see it? And then I can take the derivative of that and it's much more manageable. So the derivative of ln is going to be 1 over y times y prime. So the derivative of this expression is here. And on the other hand, the derivative of what I wrote in the expanded form is what? So this would be 1/3. Derivative of ln of x plus 1 is 1 over x plus 1 plus 5, 1 over x plus, what is this? This would be 3. Derivative is 1 over sine x, and then numerator derivative of sine is cosine x. Minus 100. Yes, derivative of x squared, of ln of x squared minus 5 is denominator x squared minus 5, numerator 2x. You agree? So it was much faster and much simpler to carry this derivative. For sine, it's just chain rule. So derivative of ln, here I'll write it in, I don't know, pink. So what is the derivative of this expression? It's derivative of ln of something is 1 over something. And that something happened to be sine. Times the derivative by chain rule of sine, which is cosine. Yes? Clear, guys? So I avoided the unpleasantness of doing a lot of product rules and a lot of quotient rules by this process. And so what do I do next? I simply then have to multiply everything by y. So the result, look at it. I need the derivative of not ln of y, but of y. Why is it 2x? Because the derivative of x squared minus 5 is 2x. It's chain rule. Yes? Do you see the chain rule, guys? So if I have logarithm of an expression, so if I take the derivative of ln of some expression f of x, what will I get? I will get the derivative of ln is always 1 over what's inside ln. So it would be 1 over f of x times the derivative of f of x, which is f prime x. So this is the derivative of ln of some function. Do you see why? Because this is 1 over f of x times f prime x by chain rule. Do you agree? Confirm if you do, guys. And so the end result is, look at the end result of what we just calculated. So the end result is this expression multiplied by the original function, by y. You see, just multiply everything by y, and y is this function. So it's the function multiplied by the logarithmic expression. Yes? Which can be viewed very naturally, guys. Look at it. If I have, if I take ln of f of x, and I take the derivative, what do I get? I get f prime of x divided by f of x. Do you agree? If I take the derivative of a logarithm of containing my function, instead of my function, I'll get the derivative of my function divided by the function. So what do I need to do to get the function? So basically, it tells me that the derivative of f of x is simply the derivative of ln of f of x multiplied by f of x. Because that would simply be f of x times f prime x times f of x. And then they cross out. Do you understand what I'm saying, guys? I mean, I think I'm understandable, but who knows? I'm very simply saying that if you decide to use logarithmic differentiation, you can take derivative of the logarithm of the function, and then to figure out the derivative of the original function, just multiply by the original function. Clear? Just multiply back by the original function. Let's see how clear it is, guys, because now you will try to figure out the derivative of a new function that you never saw before. Can you do that? I mean, maybe some of you have, but let's see if you haven't seen it. I want you to tell me, find out the derivative for the function f of x equal to x to the power of x. In other words, I want you to calculate ddx x to the power of x. There is a very easy way to do that. You can use whatever you like, sure. Zakaria, if you are correct, then ln of x to the power of x. Well, I mean, you can write it as x squared ln of x, you know. And that's, of course, if you are correct. Are you ready? Let's now do it together, guys. Would you suggest, forget about the final solution, tell me perhaps what might be a good idea to start? And of course, why would that be a good idea? That would be nice if you could mention. Okay. Thank you, Jane. So idea though, what's the idea? How would you tackle it? Why is it not immediate and how can you tackle it? Natural log both sides. Now, why, Jahin, would you take natural log of both sides? Bring x down. You see, guys, look at this expression. So I can say y is the function I want to differentiate is equal to x to the power of x. Do you agree? There's nothing I did here. I just said, let's suppose we're looking at a curve that has this graph. And let's try to measure whether or not this curve is differentiable. So if it's differentiable, what should I observe? I should observe that taking logarithms of both sides, and I do that because ln of y will then be equal to ln of x to the power of x, which then equals x ln x. Do you see that this is just product of two functions that I know how to differentiate? Whereas x to the x was a new function, because remember, guys, we dealt with 5 to the x, or we dealt with x to the 5. We know how to differentiate those functions. But we don't understand what to do when both base and power are variables. Do you agree? So here we are trying to convert to a more familiar form. So ln y is x ln x. And then what happens if I take the derivative of ln y? That would be 1 over y times y prime. Do you agree? And on the other hand, this is product rule. So taking the derivative of x gives you ln x plus take the derivative of ln x, but don't bother x, so it's this. So altogether I have ln x plus 1. Do you agree? So the derivative is ln x plus 1. Now all I have to do is multiply the expression by y. So my y prime is equal to y multiplied by ln x plus 1. And what is y? Y is the original function. It's x to the power of x times ln x plus 1. You might, I am assuming none of you are worried by that. I mean, this calculation is carried with the assumption that x to the power of x is differentiable. Do you agree? I carry this calculation by implicit differentiation, and when I say y prime, I presume that it's possible to find its derivative. I just don't give it explicit formula. You can see that this function is differentiable maybe as follows. So you can see that x to the power of x is the same as e to the power of ln x to the x, which means it's the function ex ln x. So it's a composition of two differentiable functions. So it's x times ln x is a differentiable function because each separately x and ln x are. And when one differentiable function eats another differentiable function, the result is a new differentiable function. It follows also from chain rule. You understand? All right, so let's see what we have next. Remember also the logarithmic laws 1 through 3 that you have to, well, the answer is x to the x multiplied by, in parentheses, ln x plus 1. And here I just used those laws to break the fractions down. We understood this, guys, yes? I would like you to please differentiate. Can you see it on the bottom of my screen, guys? X to the power of 3/4 root of x squared plus 1 over 3x plus 2 to the 5th power. If you could, please differentiate this function for me. All right, so we're done. Yes, wonderful. So let's look at this thing, guys. Here is this function. So I have that we write ln y is equal to, so ln y should equal to 3/4 ln x, right? Plus 1/2 ln x squared plus 1 minus 5 ln of 3x plus 2, agreed? Which means that on this side we have 1 over y times y prime, and that should equal to 3/4 1 over x plus 1/2, and x squared so it will be cancelled as simply x squared plus 1, and here you have x minus 15 3x plus 2. Agreed? And then simply multiply the result by y. This result is multiplied by y. Here is the solution written in my notes. Here it is. Clear? Yes, guys. So there's little I can do that. I mean, you should all go through the algebra, right? I mean, the idea. Do you understand the idea? That's the calculus part. Everything else is just, I mean, do algebra carefully. Don't forget chain rule. I always show conceptual questions. They're all conceptual. So here is a situation when we take the derivative of x to the alpha. We know that the solution should be alpha x to the alpha minus 1. We used it very frequently indiscriminately, even though, if you remember, and I'm not sure how many of you remember, we proved it truly for positive integers, right? I know that the derivative of x to the 5 is 5x to the power of 4 by that well, I mean, do you remember that story, guys? Do you remember? I think I told you to listen to the story Nightingale and the Rose. And that is the way you factor x to the 5 minus a to the 5. So we know how to take derivatives of x to a positive integer power, but what happens in general? What does it mean to take the derivative of x to the alpha? And why should that be alpha x to the alpha minus 1? We don't even understand expressions like x to the power of pi. Now, e to the x, guys, e to the x simply means 1 plus x squared over 2 plus x cubed over 3 over 6 and so on. And so e to the pi is understandable in that sense, because you understand I'm not taking exponents. When I understand what e to the power of something, that power is just to remind me what motivated this function. Why, but what actually is done in terms of calculation is this process. So don't think about taking e, multiplying it by itself. Think about it rather as 1 plus pi squared over 2 plus pi cubed over 6 and so on and so on. You understand what I'm saying, guys? Because it happens that that if you do this process in all instances where exponentiation makes sense, this function will behave like an exponent, and yet it extends the idea of exponentiation to non-integer powers. So for instance, if I want to take the derivative of x to the alpha, I should view this function x to the alpha in general as e to the alpha ln x. That's the way I should view this function, because it looks like e to the power of ln x to the power of alpha. I'm not sure if it's completely above you guys, but you do understand that many operations, unless you understand what the operation is doing, you don't understand the operation. So my point is, you don't understand what is x to the power of 5. You might understand what is x to the power of 2 is. So to give a sense of what is x to the power of pi, or to which is agreeing. So see, guys, what is x squared? X squared is x times x. Do you agree? X squared is x times x. What is x cubed? Well, this is x times x times x. That's how you think of such values. Yes? Now, what is x to the power of pi? I don't know. So I'm going to define, this is definition, guys. X to the pi is going to be defined as e to the power of pi ln x. Why is that defined this way? Because, I mean, if I were to move pi to the power of x, that would look like it cancels out. And yet in this form, I can calculate ln x because I know how to calculate e, and I can multiply ln x times pi, and I can calculate this expression. You see, so what is e to the power of pi ln x? That means that x to the pi tells you to do the following. It tells you to take 1 plus pi ln x plus pi ln x squared over 2 plus pi ln x cubed over 6, and so on. Do you understand? I'm hoping at least some of you do, guys, right? So x to the pi is defined to be this process, e to the power of, which is this infinite process, which we supposedly understood. What is unambiguous? 1 second. You see, so again, once again, guys, x squared is x times x, but we know that that is all definition of exponentiation. Okay, all definition that makes sense for integer powers. On the other hand, x to the power of pi, we don't know what it is, but we're going to define it as e to the power of pi ln x, because this operation is not ambiguous. Do you understand why it's not ambiguous? Because, guys, when I say e to some power, e to the box, what I mean is unambiguous. I mean to take 1 plus the box plus what's in the box squared over 2 plus what's in the box cubed over 3 factorial, and so on and so forth. If you understand that series development, then you understand it's an infinite polynomial, right? And it involves addition and multiplication, which we regard as unambiguous. Now, x to the pi can be then defined as e to the power of pi ln x, which will be, the box will simply be this this other process. This is going to be simply the box, and I can calculate ln x. I haven't shown you. Yes, so this particular box I can calculate. Assuming, of course, guys, that you understand that I can calculate ln x. I mean, I haven't derived your formulas. How do you explicitly calculate what is logarithm of something? But that can be done. We can develop formulas to calculate logarithms of something. Okay? So wait, Francis, for the derivative, I'll mention it in a moment. So x to the power of x. I'm showing a conceptual idea that might be, well, I mean, I'm not sure if it's important at the stage of your development, but I try to push you a bit there. Right, so this is what the function means. This new definition makes sense, and the derivative would be what? The derivative of e to the power of pi ln x would be what? It would be e to the pi ln x times pi divided by x. You agree? Which is, if I convert back e to the pi ln x, it looks like x to the power of pi, as it looked before, times pi over x. So in that sense, this result, when you carry this calculation, you can either, I mean, you might say it's unfair that I say, well, I don't understand this, so how can you tell me this is pi x to the power of pi minus 1? I can simply go not from this stage, I can go from that stage and say, Oh, this is e to the power of pi ln x times, oh, I can keep the pi out, times 1 over x I can write as e ln 1 over ln of, I can just write minus here, right? Times this minus. So that means that it's pi e to the power of pi ln x minus, sorry, the power of. So this minus that, and the powers will be simply pi minus 1 ln x, which is the definition for pi x to the power of pi minus 1. Did you understand? Or so it's just as a curiosity, did you understand what I just said? No, not at all. No. Anna, no, right? Jahin, no. Angela, no. Where did I lose you? It makes me wonder. Over the x. Well, let me ask this thing, guys. You understand the difference between new and old definition? So it's a bit weird. What I say I can do for x squared. For x squared, I can do two things. I can say x squared is equal to x times x. But I can also say that x squared is equal to e to the power of 2 ln x, which would be 1 plus 2 ln x plus 2 ln x squared over 2 and onwards. Do you understand? So doing both procedures produces exactly the same result for all x. You follow? For all x, it will produce, for all positive x to be precise, because ln cannot be applied to negative x, right? So for all of them, it will produce the same result. Understood? Both procedures. You can prove that. You can easily, that's what I mean conceptually. You can easily prove that. So because they produce the same result, this is the natural way to extend, right? If I want to say x to the power of alpha, and I want to understand it for all alpha, this formula only, x times x, only works if the power is a positive integer, or in general an integer, if you can extend it, right? But x to the alpha, I can make sense of it all for all values of alpha. For any number, I can make sense of it. And that, in the sense, is e alpha ln x. You understand that it's a natural extension. So this formula makes sense for all values of alpha. Good. Now, how can I show that the derivative of x to the alpha now is following the same pattern? That means that I have to use this definition. So what's the derivative of x to the alpha? The derivative of x to the alpha is e alpha ln x times, I can put the alpha here, times 1 over x. Do you agree? That's the derivative of x to the alpha. I just use chain rule. Completely agreed? Now I want to simplify the formula, guys, right? So how do I simplify the formula? This is the same as alpha e alpha ln x multiplied by e to the ln of 1 over x. Are you with me? I combine the powers for ln because you understand, I mean, I need to push it together. I want to come up with a formula in terms of some x to the power of some other power. So ln of 1 over x is minus ln x. Do you see? So this is the same as alpha e alpha ln x times e to the minus ln x. Are we so far good? Now, if I multiply the exponents, I just basically, if I multiply with the same base e, the powers, they add up. Better said, it's actually, you can prove that this happens for e to the x. You see, if you can study this, right? So what this means is that this is alpha e to the alpha ln x minus ln x, which becomes alpha e. I can factor out ln x, so it would be alpha minus 1 ln x. And look at that. This is the definition. This is the definition of alpha x to the power of alpha minus 1. Do you follow? Right? You would follow it, of course, much better if you have a sense of what you know. What exponential powers can you take? What are you able to calculate? How are you calculating them? Then it makes much better sense. Right? Other than that, it can be, of course, confusing. Since if you do not know how to calculate roots, if you cannot come up with a formula to calculate roots, if you cannot come up with formulas to calculate exponents on your own, then this procedure is, of course, confusing. All right, guys, so now it's your turn. Try to help me find the derivative. So we have y equal to ln of absolute value of x. Try to find the derivative of a, please, as quickly as you can. We're going to go through the exercises here. Good. All right. Good. Very good. So let's look at the solution, guys. So you have to be a tiny bit careful, right? It's ln of absolute value of x. So it's really a function that is ln x if x is positive and ln of minus x if x is negative. So if I take the derivative when x is positive, I get 1 over x. If I take the derivative when x is negative, it's the derivative of ln of minus x, which will be minus 1 over minus x, which is still 1 over x. So that means that the derivative of ln of absolute value of x is 1 over x for all values of x. That's going to be important later on. That allows us, because look at it, ln of absolute value of x extends the definition of logarithm to both negative numbers and positive numbers. Right, from positive numbers we can extend to negative, to be precise. And then the next question is derivative of ln of sine x. You understand? Whenever you see ln of absolute value something, it's just going to be 1 over what's inside the absolute value. Is it clear? So what do we get? Well, the derivative is sine on the denominator. Derivative of sine is cosine. So cosine over sine is cotangent. Good. Now please calculate c. Guys, y equal to log base 3 of e to the x. This one is very easy. Very easy. So very easy. Okay, so take the derivative of this expression, guys, and what do you get? Derivative of logarithm is what? It is, in this case, you can just simply write it as log base 3 of e times x. So the answer is simply log base 3 of e, and you don't need to do anything. Do you agree? If you drop down the x, then there is nothing to do. Well, okay, Jahin, let's see about the absolute value. Do you agree that if I want to differentiate absolute value is a bit a nasty function. It's a piecewise function. I then break into cases where x is positive and where x is negative, because then I can replace absolute value by either just eliminating it if x is positive, or by multiplying by -1 to make the number positive. Do you agree? So you see, ln of minus x, if x is negative, it requires an extra -1 to make it positive, to make x positive. So we have this partition here. And then I can take derivative in the case where we use this formula, and I can take the derivative in the case where this formula is used. And the result is exactly the same for both, which means that the derivative of ln of absolute value of something is 1 over what's inside absolute value. Good? All right, so then guys, please calculate d. Calculate d as fast as you can. It's sine x times ln of 5x. Please figure it out. All right, so a lot of you solved D. Let's do that together, guys. So here it is. It's just simply, I mean, I decided to split it up. You don't even have to do that. So the derivative of sine is cosine, derivative, and then I don't bother this. I just leave it as ln of 5x. And then sine times the derivative of this expression, which is simply 1 over x. Good? I split it, but I mean, it's not a big deal if you don't, you get the same result pretty quickly and pretty easily. Then please solve question number E. All right, so let's do E, guys. Ready for E? So naturally, what should you do, guys? Look at it, it's x times e to the x. You would like to split it up. You don't want to take the operations, what for, right? So you would just apply logarithm first. So first you say that this is logarithm base 5 of x plus x logarithm base 5 of e. Take derivative of that expression, that gives you 1 over x ln 5. And this is plus logarithm 5e. Clear? All I did is I applied logarithm before taking the derivative, because logarithms do very nicely against multiplication and division and powers. They make it simpler. That's why we like them. Good. And of course, then f, I mean, you understand how to do f. Do f quickly, just to prove that you do understand how to do it. All right. So for f, guys, last question, let's finish it. So we first break it apart. It's 5 ln of 2x plus 1 minus 1/2 ln x squared. So derivative of the first chunk is 5 2 over 2x plus 1 minus 1/2 2x over x squared plus 1, and you get 10 over 2x plus 1 minus x over x squared. Right? Yes. Just put the bottom in parentheses. And we are done with that, guys. There is those questions here, x to the a, all those questions we will try to deal with on Thursday, and then we will begin talking about inverse trigonometric functions, which of course is a very old topic, because you realize that inverse trigonometric functions are just trigonometric functions that you view from the side, like this. Yes? Same function, but you place your head horizontally. All right. So I wish you auf Wiedersehen, goodbye, take care. Unless you want to play a what when where game or you have questions, take care, guys.